Troesch homework number 1. Alright, solve the nonlinear inequality. Express the solution using interval notation and graph the solution set. So first of all, let's just do number 29. So number 29, x plus 2 times x minus 3 is less than 0. And what this is basically asking us to do is, for what values of x will this inequality be true? So for example, if I plug in, let's say, 4 into x, right? If I plug in 4 into x, I will get 4 plus 2, which is 6, times 4 minus 3 is 1, so 6 times 1 is 6, and then 6 is not less than 0, so this wouldn't work. And basically what I'm trying to do is find out which x values do work for this inequality. So which x values would make this inequality true. Now, first step you're going to do, for this first problem, it's actually pretty convenient, because normally the first step of solving this types of inequality is you want to move everything to one side so that the other side is equal to 0. However, they already did that for us, so we don't have to worry about that. Now the second step is you want to pretend that this is an equation, and you want to find out for what values of x make this 0. What values of x makes x plus 2 times x minus 3 equal to 0. And when x is equal to 3, you'll notice how 3 minus 3 is 0. 0 times anything is 0. So this makes it true. And if you plug in negative 2 in for x, well, negative 2 plus 2 is just 0. 0 times anything is 0. So 3 and negative 2 are our numbers. Now, because this is a less than sign, it's not a less than or equal to sign, you're going to use open circles. So, you're going to draw a number line. You're going to highlight the critical points, which are just the points that make this equal to 0. And then, if there's no equal to sign, well, you're going to draw an open circle. If there is an equal to sign, you would shade in these circles. But in this case, it's only less than, so we do not shade in the circles. Alright, now in order to find a solution to this problem, you notice how when we drew out our critical points for this problem, you notice how it divided our number line into 3 sections. And what we want to do, this is kind of like guessing and checking. You're basically going to test out a number from every section to see if it makes the inequality true. So right now, let's test out this section. So this section looks like numbers that are greater than 3 to infinity, okay? So let's see. If we plug in a number greater than 3, let's say we plug in 4, what's going to happen to this equation? Or inequality, sorry. Well, if I plug in 4 here, 4 plus 2 is 6. When I plug in 4 here, 4 minus 3 is 1. And 6 times 1 is not less than 0, meaning that numbers greater than 3 do not work for our solution. What about numbers that are in between negative 2 and 3? What's a number in between negative 2 and 3? Most obvious one, probably thinking of, 0. If I plug in 0 for x right now, if I plug in 0 for x now, I'm going to get 2 times, if I plug in x here, I'm going to get 2 times negative 3, which is negative 6. And negative 6 is less than 0, which means that numbers in between negative 2 and 3 work. Now let's see numbers below negative 2. Let's see if those numbers work. If I pick a number below negative 2, let's say negative 3, well, what's going to happen to the inequality? So we're going to have negative 3 plus 2, which is negative 1, times negative 3 minus negative 3 is negative 6. Negative makes a positive. This is going to be equal to 6, less than 0, which is not true. And if the inequality is not true after you plug in the x value, well, this part doesn't work. So that means our solution set is x values that are not including negative 2. They're in between negative 2 and 3, but not including them. So in interval notation, you would write that x is greater than negative 2, but not equal to negative 2, and x is less than 3, but not equal to 3. Right? Open circles indicate that it's not equal to that specific number. While if it's shaded in circle, well, that means that it's greater than, in this case, it's greater than and equal to, negative 2. In this case, it's open circle, which means it's not including that number. Now let's do problem 31. X times 2x plus 7 is greater than or equal to 0. All right, let's begin. So first of all, the first step when doing these problems is you want to move everything to one side so that the other side is equal to 0. However, they already did that for us, so we don't have to worry about that. All right, the real first step is that, once again, imagine if this was an equation. Imagine if this was an equation. What values of x make this equal to 0? Well, when x is equal to 0, and whenever you're doing these types of problems, always draw a number line, all right? So we have your number line ready to highlight what values of x make this equal to 0. So when x is equal to 0, it looks like this is going to be equal to 0. This whole equation is going to be equal to 0. And let's see, what values make 2x plus 7 equal to 0? This is just a zero product property. I'm assuming you know it. So this is, you subtract 7 from both sides. Negative 7 equals 2x. And then after that, divide both sides by 2. So that the x value, the second x value that makes this equal to 0 is negative 7 over 2, which I'm going to plot here. Now, because this is a greater than or equal to sign, we're going to have shaded in circles. So instead of an open circle like we did last problem, because it has this greater than or equal to sign at the bottom, well, we're going to have shaded in circles, meaning that it includes that number for the solution. Okay, now, once again, you notice how our number line is divided into 3 sections. And we're going to test number from every section to see if this makes the inequality true. So let's see. This section looks like it goes from 0 to infinity. So let's test out a number in between those two. Let's say we plug in the number 1, right? 1 is part of this range. So if we plug in 1 for x, you'll notice how this is positive, right? We have 1 times, and then this number is also positive, right? 1 times 9. Meaning that a positive times a positive number, well, that's going to lead us to a positive number, which is 9. So which means that, it's going to be greater than 0. So positive times positive is going to give you positive, which is greater than 0. So that means that this part of the number line works for our solution set. Let's see. Let's look at numbers in between negative 7 over 2 and 0. The one number I'm thinking of is negative 1. So let's see what happens if we plug in negative 1 for x. If we plug in negative 1 here, we have negative 1 times 2 times negative 1 is negative 2 plus 7. And this is going to be negative 1 times 5, which is negative 5. And negative 5 is not greater than or equal to 0, which means that numbers in between this range do not work. Finally, let's look at numbers in between this range. Numbers that are less than negative 7 over 2. Let's say if we plug in negative 3. Let's say if we plug in negative 5. So this is going to be negative 5 times 2 times negative 5 is negative 10 plus 7. This is going to be negative 5 times negative 3, which is equal to positive 15 because negative makes a positive. And 15 is greater than 0. Which means that this right over here, numbers that are less than 7 over 2 work, right? So that means our solution set in interval notation, well, that's going to be any value of x that is greater than or equal to 0, right? Because can't forget the equal to sign from our original thing. Any x value that's greater than or equal to 0, well, that would work. And it looks like any value that's any x value that's less than or equal to negative 7 over 2, that also works. Now let's do problem number 33. So we have x squared minus 3x minus 18 is less than or equal to 0. So first step, it's kind of already done for us, right? When we move everything, we already have everything moved to one side, so that the other side is equal to 0. However, the problem is that it's not clear what x values to plug in that make this equal to 0, which is why you have to factor. Once again, I'm assuming y'all know how to factor for this video, sorry. So if you factor this thing, it's going to be equal to x minus 6 times x plus 3 is less than or equal to 0. And now you'll notice how it's very clear what x values make this thing equal to 0, right? If you plug in a 6 for x, well, that's going to make this equal to 0. And when you plug in a negative 3 for x, that's going to make this equal to 0. Because there's a equal to sign at the bottom, it's less than and less than or equal to, well, you're going to have shaded circles because it's including that value. Once again, same strategy as before. You just want to test everything from each range and see if it works. So when x is greater than 6, let's say if we pick a number like 7, we plug in 7 for x. 7 minus 6 is 1, and then you have 7 plus 3 is 10. 10 times 1 is 10, and 10 is not less than or equal to 0, which means that numbers in this range do not work. Let's test out a number in this range. Let's say if we plug in 0 for x. So you have negative 6 times positive 3, which is negative 18, and negative 18 is less than 0, which means that numbers in between this range work. Finally, let's test out numbers that are less than negative 3. So if we have, let's say, negative 4, plug this into x. Negative 4 minus 6 is negative 10. Negative 4 plus 3 is negative 1. Negative 10 times negative 1 is positive 10. And positive 10 is not less than or equal to 0, which means numbers in this range do not work. So that means our solution is that numbers that are in between negative 3 and 6, including those values. So in interval notation, you would write this as x is greater than or equal to negative 3 because it includes this value, and x values that are less than or equal to 6. So it's in between this. That's going to be our answer. Now we have problem number 35. 2x squared plus x is greater than or equal to 1. First step, remember, you want to move everything to one side so that the other side is equal to 0. Which means that in order to get this side equal to 0, what do we have to do? Just subtract 1 from both sides. So that this positive 1 and this negative 1 cancels out to be 0. And we get 2x squared plus x minus 1 is greater than or equal to 0. Now, this part, once again, you got to factor, right? Because right now, it's not really clear what x values make this equal to 0. However, we can change this by factoring. And specifically, we're going to factor by grouping. So, in case y'all don't know what factoring by grouping is, I'll actually show this one, because why not? So first of all, you're going to multiply the coefficient of the x squared term by the constant, so the number without an x term, and you're going to get negative 2. Now you want to take a look at two numbers that multiply to be negative 2 and add up to be the coefficient of the x term. So in this case, the coefficient of the term with the x is just going to be 1. So you want to take a look at two numbers that multiply out to be negative 2 and add up to be 1. And the correct combination is positive 2 and negative 1, right? 2 times negative 1 gives you negative 2. However, if you add these two things together, you get positive 1. So 2x squared plus 2x minus x minus 1 is greater than or equal to 0. So now you notice how we use the coefficients, we use these two numbers that we've gathered, and now we just kind of separated the middle number, the number with the x. We separated the term with the x into two other terms using the coefficients that we have gotten. And finally, we can now factor. So it looks like these two numbers, they share a 2x. So we can take a 2x out from there. So we can get 2x times, if we take a 2x out of 2x squared, we're just going to be left with x. And if we take a 2x out of 2x, we're just going to be left with 1. Minus 1 times x plus 1, right? If we take out a negative from x, we get positive x, and if we take out a negative from -1, we get positive 1. Notice how these two terms are now the same, which means that you can kind of group these things together. So our answer, well, it's going to be x plus 1 times, and then what you do is you just group this remaining part together, 2x minus 1. And that's going to be our factored thing. All right, so you just take one of the copies that you have, slap it on there, and then you take the remaining things and you just slap it on there, and that's your factored expression. So when we factor all of this, we get x plus 1 times 2x minus 1 is greater than or equal to 0. Now, what values of x make this equal to 0? And we're going to plot them on our number line. So obviously, if x is equal to -1, well, this whole thing is going to be equal to 0. And 2x minus 1 has to be equal to 0 if you want this whole thing to be equal to 0. So you're going to get, if you add 1 to both sides, 2x equals 1, x equals to 1/2. Okay. So now that we have our critical points, and don't forget that because this is a greater than or equal to, this equal to tells me that this is going to be a shaded in circle. It's going to include that point for our solution set. So we have these shaded in circles. And now, once again, we have 3 sections. And we do the guess and check thing, right? So let's say we pick a number that's greater than 1/2. Let's say we pick 1. If we plug in 1 into x here, we get 1 plus 1 is 2. 2 times 1 is 2. 2 minus 1 is 1. 2 times 1 is greater than or equal to 0. Well, 2 is greater than 0, so that means that numbers in this range work. Numbers that are greater than 1/2 work. Let's test out numbers that are in this range. So a number that's in between -1 and 1/2, that should be 0, right? That's one of the options. If we plug in 0 here and 0 here, we get 1 times -1, which is equal to -1. And -1 is not greater than or equal to 0, meaning that numbers in between this range do not work. Finally, if we have numbers that are below -1, let's say we pick -2. Oops. All right, -2. -2 plus 1 is -1. -2 times +2 is -4. -4 minus 1 is -5. Negative makes positive, and we get +5 is greater than or equal to 0. Yes, it is. This is true, meaning that numbers in between this part is going to be part of our solution. So, the final answer, well, it looks like numbers that are greater than or equal to 1/2, x values that are greater than or equal to 1/2, looks like they work, and it looks like x values that are x values that are less than or equal to -1, they also work. And that's going to be our answer. All right, now let's do problem 37. We got 3x squared minus 3x is less than 2x squared plus 4. So, first step, you want to move everything to one side. So in this case, we can move everything from here to this side, or we can move everything from here to this side. Doesn't really matter, but in this case, just for the sake of convenience, I'm going to move everything to this side, to the left side. And you're going to see why. So if I subtract 2x squared and I subtract 4 from both sides. Now obviously, all this will cancel out to be 0. So you're going to get 3x squared minus 3x minus 2x squared minus 4 is less than 0. Notice how this 3x squared and this 2x squared cancel out to be just an x squared, right, and 1x squared. So this cancels out. And we are left with x squared minus 3x minus 4 is less than 0. It's unclear which x values to plug in to make this whole thing equal to 0, which means that it's time to factor. So doing some factoring, trinomial factoring, we get x minus 4 times x plus 1 is less than 0. And now it's pretty clear what x values make this 0. X is equal to 4 when this is 0, and x when it's -1 is equal to 0 at this point. Because it's just the less than sign without equal to part at the bottom, we are going to do open circles. Once again, 3 sections, you know the drill. Let's look at values here. If we plug in a 5 here, right, of something that's greater than 4, right, something in this range, plug in a 5 here. 5 minus 4 is 1, 5 plus 1 is 6, 1 times 6 is 6, and 6 is not less than 0, which means that numbers here does not work. Let's try to pick a number in between -1 and 4. That should be 0. So if we plug in a 0 here, we get -4 times 1, which is -4, and -4 is less than 0, which means that numbers here do work. And finally, let's take a look at numbers in this range, numbers less than -1. So if I plug in, let's say -2. -2 plus 1 is -1. -2 minus 4 is -6. -6 times -1 is +6. 6 is not less than 0, so numbers here do not work, which means our solution in interval notation, well, it's going to be x values. It's going to be x values that are greater than, but not including, -1, and x values that are less than 4. And that's all.